Welcome back on board the Starship, and we're talking with Anthony Beckett, who is looking for life on Mars. And in the mid-1970s, there was two very interesting probes landed on Mars, wasn't there, Anthony? They were the Viking mission. Tell us about that. They were two identical craft, am I right?
The two virtually identical landers basically dropped onto the Martian surface. It was the first time that obviously they got to a surface of Mars. They sent probes beforehand. Mariner 9 a few years earlier, I think 1969, had gone into orbit around Mars and stayed there for a few years. But it wasn't until the Viking missions in '75 which they actually planned to get two landers onto the surface. And we have this image to show, which shows the NASA scientist and astronomer, famous astronomer called Carl Sagan, stood next to what is a mock-up of what the Viking lander looks like. So you get an idea of scale there.
And these things couldn't roam around the surface, they were just in a fixed location.
Yeah, it was a static lander.
So they chose two locations of interest, which then sent back data.
So they sent it there to look for geological information, but also it had a biology mission as well. It had like a biology experiments on board. So when that probe was put down in situ on the planet, they had to just they just had to hope that they landed somewhere where they could take reasonable samples that were representative. So shall we move on to the next slide?
Yeah. So this is another one from the surface?
Yeah, this is the first image to be beamed back from, I forget which one of the two landers, I'm sure it must be Viking 1 considering. But the first image to be beamed back was, this image, and it shows what is unusual for what we'd consider to be an image for planet Mars, because if you browse around the NASA website, you'll see another idea of Mars. But in this first image, what you see is kind of a light, whitish, pale, kind of a pinkish hue to the sky, and brownish rocks, and obviously the lander. Nothing much there. It looks very barren, very desert-like. But later on in the mission and the day as well, as it happens, we go on to the image. We see more images like this, which shows Mars with a clear blue, bright blue in this case, sky. It's kind of interesting because if you read a magazine or newspaper articles about Mars, and it's a red planet. We don't know it's a red. We know of it as the red planet. And we make an assumption, and that it has a red sky, but maybe that's not quite true. And it wasn't a one-off because most of the photographs from Viking showed Mars with a blue sky. And there are exceptions. There's a really a nice image of a sunset which basically looks red, but we'll get red sunsets on Earth, so that's nothing special. And having a blue sky on Mars isn't unusual because the whole physics of why you have a blue sky on Earth is to do with the process called Rayleigh scattering. It's about the kind of scattering of blue light predominantly over red light. And because of the chemical makeup of the Martian atmosphere, being predominantly 95+% carbon dioxide, albeit at like less than 1% of the Earth's atmospheric pressure, we should still see the same physics in action. We should still see a blue sky on Mars. And, 1970s we did.
Okay. Now, in later probes, we seem to have the colour of the sky changes through 97 and 2004. Tell us about this. Yeah,
well, in later missions, we've mentioned Mars Observer, which was 1993. It was supposed to be going out in orbit, I think it was, but that obviously failed. It was another 3-4 years later. It was 1997 when the Mars Pathfinder mission finally got to Mars again.
Right, this was a successful one.
We've got this next image which shows you an example of a couple of images from Viking at the top. The middle two images are from the NASA Pathfinder mission, which show they're representative of what you'd see if you browse the websites for the mission images. And you see kind of a brownish red sky on the Pathfinder mission ones. Then you come to 2004 with the Mars Exploration Rover mission, which had the two rovers, which we'll speak about later, roaming around. Now this show a brownish but also a deep red sky, and also in some of the images we see a very deep red terrain as well. So what we've seen here is over the period of what is 30 years, we're seeing the change in the Martian sky from blue through to a deeper red.
And you would contend that NASA have basically doctored those images for some particular reason?
I can prove they've doctored the images.
You can prove they've doctored the images?
What I can't prove is the intent behind that. But
the intent behind it, okay. Now, you showed me a very interesting image earlier, which was is it the sundial?
Yeah, this is a panoramic image from one of the landing pads. I think it's one before Spirit rolled off the landing pad.
Yeah.
And you see in the centre, at the bottom, you see something called, it looks like a bit of a computer joystick.
Yeah.
It's a colour calibration target. And in this this image here we've seen like it's zoomed in, it's close, it's zoomed in on it. Well, you'll see...
That's it, looks like an old Atari joystick,
it doesn't it?
Remember
yeah.
them?
So you see on the corners of the joystick.
Yeah.
They call it the sundial, and it basically shows the angle of the sun, and it's also got like grayscale images which show the intensity, light intensity, and also on the corners, it has 4 different colours. It's got red, green, blue, and probably yellow. I can't remember. We'll see the next
green
image.
it'll be.
I can't remember. Yeah. Oh yeah. And so, but what we've got on this one is the bottom right corner is bright red, really radiant red, and the other 3 corners are quite equal in tone and colour. Look brown. The bottom left is kind of dark brown, but the top 2 are identical browns. And it's like, well, okay, the calibration target was designed for a reason. It's called a calibration target for a reason. It's used, or it's intended to be used, so you can calibrate the images properly, so you can see what the lighting characteristics are like on that image. So this image is clearly uncalibrated. No one has gone out of the way to actually calibrate the image.
So let's have a look at that. That is an actual picture of the object from on Earth.
Yeah, this is like a lab technician holding the display. So you'll see that the bottom right image, the bottom right bottom right colour target is blue.
Blue.
And the top left one is green.
Right.
But if you remember back at the original image, it wasn't showing green, it was showing green as brown. People have argued that the reason the blue comes up as bright red is because the Mars really has a red atmosphere, and red light comes down, so predominantly everything's bathed in a red light. Well, all you need is GCSE. You don't need to pass your GCSE physics to know that when a blue object absorbs light and it emits blue light, a blue object that absorbs that only is bathed in red light will never emit red light.
No.
It can only emit blue light. That's its characteristic.
Yes.
So that proves that the image is not uncalibrated. It's not to do with ambient red light.
It might be darker because there's lack of light, but it's not going to be bright red, is it?
No, exactly. That's it. See, that proves that the image is uncalibrated.
Yeah.
The problem is that NASA have been in the press releases put out these images as being the true colour images of Mars. Some images say the false colour, and occasionally what they will do is, in this particular slide here, it says not the true colours of Mars. What it's showing is an explanation from NASA about what they do, and they basically said they take the green and the blue channels. Each of the eyes and cameras record 4 different wavelengths. So red, green, blue, and then infrared. So what they actually do is take the green and take the blue, but rather than showing red as red, they show infrared and then render it in the image as red. So they're actually showing a supersaturated red image. There's technical reasons why they will want to do that. You see more information about the kind of mineralogy and geology basically by doing that. So there's scientific or technical reasons for wanting to do it.
Yes.
But at the same time, these images are being peddled as the real true colour of Mars, which they are clearly not.
So they're doctoring images, basically, of Mars.
Yeah.
Yeah. Okay. And it's anyone's guess as to why they don't want people to think that Mars has got a blue sky and it looks very similar to Arizona or somewhere like that.
It's kind of interesting because if you go back to the original Viking missions in the 70s, which had blue sky, if you look at the actual images as they are on the Jet Propulsion Laboratory's website, which is a part of NASA, it seems they're showing slightly different tints in the original images. So I've got a few examples of the poorly calibrated Viking images where they seem to have gone out the way to make these images redder, which were originally blue sky. So much so that the one that I've shown on the left shows the American flag, but rather than it being red, white, and blue, it's red, white, and purple. There's two. They've gone a bit overboard with the kind of saturation of the red there. Yeah. Well, at the same time, just prior to the Mars Exploration Rover program, which started in 2004, I think the landers landed in January of 2004. There was a press conference. I think it must have been the year earlier, I'm sure. But, I don't actually know the exact date.
So these were identical landers, weren't they?
They were identical
These ones
landers.
could move around the surface as well.
Right.
So this is 2004.
In fact, in this image, you can see a mock-up of one of the landers on the desk next to the press conference table. So you see the solar cells at the back, and you see the head with looks like the little robot from Short Circuit, the eyes. And that's basically a small mock-up of what they look like. Well, at this particular press conference, they showed a big picture behind the press conference, behind the scenes, showing an image of Mars. I think it's from the Pathfinder mission, which it showed Mars with a blue sky.
Right.
So still, back in the mid-90s,
Pathfinder 96.
We have an image of Mars with a blue sky.
Blue sky.
So why are they showing all these images? Why in the newspapers and books does it say Mars is red?
So maybe that image there, that conference, was an undoctored NASA image, perhaps,
Maybe,
that
well,
the scientists have access to.
undoctored is a bit strong. It
Yeah.
might be just that it's well calibrated.
All right.
But, I'm
Yeah.
kind of nice on them sometimes. I'll
Yeah.
give them the benefit of the doubt.
Okay.
But,
Right.
but of course, there may be a reason why they would want to suppress certain colours on the surface of Mars.
We can come on to that.
Yeah.
Now, the 1976 probe, which was the Viking,
Obviously, yeah.
that's the only mission that intended to try and find out life. Is that right?
It's correct in one sense. I call it the first and last exobiology expedition, simply the fact that it had biology experiments on board which were designed to detect microbes actually in the soil.
Right. So how do they define that, and how do they say, well, this is life or this isn't life? What's the experiment that they use to say that there's life there?
In fact, that was one of the dilemmas of the scientists from the 60s up from. I think NASA gave its first contract to somebody to investigate just that problem. It's a guy called Wolf Fishnack. I don't know whereabouts he was from. He was working from some university in the US, and he was tasked with looking into that exact problem. And he came to the conclusion that a lot of scientists were thinking that you send a probe to Mars. If there's such things as plant life, you can take pictures of it, but even on Earth, you don't get plants everywhere, but you tend to get microbes everywhere. They're kind of ubiquitous on the planet Earth. So the assumption was that microbes would similarly be ubiquitous on Mars. So they focused on just looking for microbes, and then they have the problem of, well, does it still use the same chemistry as you find on Earth? Or does it?
Is it carbon-based?
Is it carbon-based? Does it need water? I mean, they basically made assumptions based on the knowledge of terrestrial life. And there's ideas obviously that you can have silicon-based life, but even within the carbon-based life system, you can have, you can have like what we now know as extremophiles that live and breathe and feed on, various different chemicals and use different chemical processes that wouldn't be we don't find everywhere else. And it was interesting because back in the 70s when this mission was developed, they didn't know about extremophiles. They were discovered in the late 70s when the hydrothermal vents were discovered and stuff. So when Viking went to Mars, they were looking for regular microbes, not what we'd consider extremophiles.
So, and what did it find? What was their conclusions from that?
Well, of the three experiments that finally went, the one was called label release experiment, one was a pyrolytic release, and one was the gas exchange experiment. All were designed to elicit a kind of response from take a sample of soil. Two of them fed a nutrient solution to the soil in the hope that if there was any microbes, it would feed on the solution and then produce a gas which could then be measured. And the gas exchange experiment was basically designed to see if there were any gases given off which would be indicative of life. One of the problems being that there's so many ways you can look for evidence of biochemical actions. There's a lot of chemicals you can look for, which basically there are both biological and other mineral processes for its creation. So they had to design an experiment which basically looked for how a chemical process would make something. And the general idea is that chemistry happens faster than biology. So the time frame for a response was critical. Well, anyway, in the criteria they set the criteria which basically meant they had a positive. Anyway, one story short, because we're running out of time. They had a positive response for the label release experiment. It gave a positive signal for showing life, and the control showed, which is what they expected, nothing there. The pyrolytic release showed a similar example of a positive result, and the gas exchange just didn't respond to anything. It didn't seem to detect anything. That basically, in their own criteria, said, "Look, we found life on Mars. We found evidence for microbes on Mars."
So there was evidence for microbes.
Yeah, they were concerned because the response wasn't as fast as they once, the hopes. So it was kind of what you'd expect to get from a result, say from the pyrolytic release experiment from a sample of soil from Antarctica.
Right.
And so it was actually in the right ballpark, but the questions arose because it seemed to be that was actually both chemistry and biology happening. So some of the response was to do with chemistry.
Right.
And some was biology. Also, what they found from the response was that it died off, it tailed off too quickly than what they expected. But as has happened in recent years, people have shown that the reason, well, if you consider extremophiles, you can kill extremophiles by just giving them the same kind of nutrients that would kind of other microbes live off. So it's very likely the reason the positive response tailed off at the end was because they're not terrestrial microbes. It's not life like we know it, and we just killed them by giving them the wrong kind of foods. But what we did get was a positive signal of life, which to their own criteria was basically test positive for life on Mars.
Right.
It was challenged from another angle as well, because the gas chromatograph, which was there to detect organic molecules in the atmosphere, didn't do that. It didn't do its job. It didn't detect what did its job, but didn't detect organics in the atmosphere. Well, the same device didn't detect organics on Antarctica.
Right.
And it was always argued, the case was always argued that the sensitivity of the GCMS which wasn't nowhere near the levels what you get from the pyrolytic release and the label release experiment. So you could never disprove a positive of the other two experiments with that.
Right.
But that's exactly what they did. They used the GCMS results to wipe their hands clean of a discovery of life on Mars.
So would you say that the results were inconclusive then? Is that in summary?
I would say they were conclusive.
They were conclusive, which was that there is
Test positive for microbial life on Mars.
Microbial life on Mars.
I'm not the only one to think that. There's many kind of astronomers who there's a guy called David Darling wrote a really good book actually, whose the title I forget, but he's been outspoken about this one. Quite a few people have been as well.
Okay, so in other words, NASA are interpreting those results differently to what some scientists are. Is that what?
Yeah, it's been claimed that basically what's happened is, we mentioned the Brookings Institute report before. One thing that actually stated is that if they did find evidence of albeit intelligent life, they would not necessarily release it to the public. And I think what we have here is a case where they discovered not intelligent life but just life, and it was such a big paradigm shift for the people. They were either too scared to go ahead with releasing it and acknowledging it, or maybe there's another reason behind it, but for some reason they decided to keep it behind closed doors.
Right. Now, after that point, after the mid-70s, none of the other missions specifically searched for microbial life. They just knocked it on the head for whatever reason.
Yeah.
But there was one probe which had a microscope analysing some of the ground.
Yeah.
And which wasn't specifically looking for life, but it's a very interesting image.
Well, it was looking. The other missions, I say that Viking was the first and last exobiology expedition, but the other missions have been set to look for things that would be conducive to life. So they have been looking for evidence of the potential life, but never direct evidence for life. But what they found, like what you're referring to with the Phoenix lander, is quite intriguing.
What year was that one?
This was in 2007. I think the images we're going to show was from 2009.
Right, from the Phoenix Mars lander. This is a very recent one.
There's a researcher called Ron Bennett who he took the original frames from NASA, the initial images that came from the microscope, which is basically looking at soil samples, and put the red, green and the blue channels all back together because they were in separate images, and put that into a sequence and looped it. And what it showed was very intriguing evidence of things that moved beneath under the microscope of Mars Phoenix lander.
Right. So, and there's contention over whether that's actually life moving around or whether it's just been blown around. I mean,
contention's not there. In a sense, NASA haven't been looking at it. NASA haven't officially or openly discussed it. Ron Bennett is the only person I'm aware of who has actually done this work.
Right.
But what he's showing is we'll show the image in a second. But what he's showing is evidence for things moving on the surface under the microscope. Well, you can interpret that how you like. Just see the image for yourself. See what you think.
Am I right in thinking that Arthur C. Clarke claimed that there were trees on Mars? Yeah,
Arthur C. Clarke was the science fiction writer. Was convinced until the day he died that the images returned from Mars Global Surveyor in 1999 of a region around the South Pole of Mars showed structures which he believed they were trees. They were a Martian plant life. It's interesting because up until recently, NASA hadn't been looking at them, hadn't acknowledged. Well, they've not looked at them at all in the context that there might be biology. They call them they've returned to. I think it's actually the Mars Express. I think high-rise camera returned to Mars and took more recent photographs in high res of the same objects which we're going to show. And they basically NASA claim that there's no objects like this on Earth, so they're completely unique to Mars. Well, I beg to differ because you see things like this all the time. They're called trees. It doesn't prove they are trees. It means they look like trees. They have the dendritic patterns of things branching out, which you kind of get from watercourses as well. But they're not unique to just biology.
Yeah.
But what the point here is that NASA haven't dealt with the evidence as evidence for
Right.
potential trees, despite back in the 50s saying that's one of the things they would look for.
Right. So it could just be minerals or something like that, but then again, you think it could be
It could be minerals, but
something
at the
similar
same,
to a tree. You think it
actually,
could be?
yeah, it could be minerals, but then at the same time, one of these objects is actually 500 meters across.
Uh-huh.
And okay, that seems quite big for a tree, but just think like redwoods or something. But there's actually trees on Earth that grow to that size and have more of comparable dimensions as well.
Right.
There's the banyan trees that kind of well, there's one in the
Or it could be a coral, like a reef
exactly
or something
well,
like that.
yeah, it's like a mineral still, but it's obviously biological origin.
Right.
So yeah, another angle. So yeah, the point is that NASA haven't looked at it as evidence for biological life.
Okay then, Anthony, well, we're coming up to a break now, and after the break we were going to talk about evidence of intelligent life on Mars.